Hello everyone and welcome to the SANS special webcast titled DFIR Techniques Using the SIFT Workstation. I am Alex Bass with the SANS Institute and I will be moderating this webcast. Today's featured speaker is Rob Lee. He is the Curriculum Lead of Digital Forensics and Incident Response at the SANS Institute. Before I turn things over to Rob, the Q&A portion of this webcast will take place throughout the webcast. Please feel free to submit your questions at any point by using the chat window, and we will answer them as they come in. Right now, I would like to hand over the mic to our first featured speaker, Rob Lee. Rob, would you like to take over?
Thanks, Alex. I really appreciate that. Hello, everyone. My name is Rob Lee. Alex did a really nice introduction for me online, and I really appreciate that. Just looking through the participants here, I see a lot of old friends and a lot of new ones. So hello to everyone. Hi, Jeff Tam, and others that I'm seeing on the list, Mark Gagne, and a bunch of others I'm just going through and just seeing the quick Doug Burks and others. So glad you guys all could come out and hang out with me and discuss the SIFT Workstation. The SIFT Workstation is a project that I started for the Forensics 508 class probably about 6 years ago now. And it's really taken off in terms of a lot of different people requesting it. The kind of the history of the SIFT Workstation is that after about a few classes, I noticed a lot of the students would come back up to me after class when they come back and take other classes at SANS and say, hey, can I get the latest copy of it? And we discussed, it was probably about 4 years ago now, that with the SANS Institute about possibly putting it online. And that, after some back and forth about the download size and the bandwidth and everything else, the SANS Institute agreed to hosting it, and I started converting the SIFT Workstation, instead of being a classroom-only tool, into something that is particularly used by a lot of different individuals that are out there. And in doing so, I've actually gotten a lot of volunteers along the way to help me out with new tools, testing it, and a bunch of other different capabilities in it. Now this session is meant to basically help those who are not familiar with the SIFT Workstation see some of the capabilities in the SIFT Workstation, what it can do, what it can't do, why someone might like to add this as an augmentation tool to your current toolkits, and the future. And I'll talk about the future a little bit later on as we're moving toward what I've now named SIFT 3G. Which is the third generation of the SIFT Workstation. Before I begin, I just want to quickly point out that for those of you from the European side of the pod, we are going to be at SANS Forensics Prague in 2012. This October, myself, Chad Tilbury, Lenny Zeltzer, Jess Garcia are all going to be teaching over there in Prague from the 7th through the 13th, and we're also doing a one-day mini summit at the beginning of this, where we're going to be inviting speakers from around EU to come and join us to talk about digital forensics over in the European continent. So I'm really excited about that. I haven't been to Europe in quite a while, and we've had a lot of requests over there to start expanding our forensics presence. So maybe we see a lot of Europeans come over to the US to take courses. Maybe we'll get some from the US to head over to Europe and a mini vacation to go spend it in Prague. It's a great city, and for those of you beer lovers out there, it's a great beer city too. So the SIFT Workstation, this presentation, as I said before, the aim of this, and what I hope to show you throughout this presentation, is a basic intro to the SIFT Workstation, what it can do, what it can't do, and also talk about the future of it. The SIFT Workstation, I list this slide for the overall digital forensics incident response curriculum, but it also talks about where you could download the SIFT Workstation from. If you look at the middle of the slide here on the left-hand side, there's a link. Now the SIFT Workstation is completely free. It's GPL, so anyone else out there can use it, and all the tools on it are either GPL or re-up permissions from the authors to be able to distribute their tools, and also that others can use it. We only ask, if you end up using it in another course, we've actually had a lot of universities start using the SIFT Workstation, that you just credit the SANS Institute for the creation of it. That's the only thing that we request, is just giving us a nod for the product. That way the team that's currently working with the SIFT Workstation and developing the future components of it will still get the recognition that they so deserve for keeping this thing up to date. So there's actually two different SIFT workstations out there. There's a Windows 7 version, which you would receive if you come to our initial course, Forensics 408. And then if you come to any of the other classes, which includes our new, brand new Forensics 508 class, we really step you through some of the advanced capabilities built into the SIFT workstation. And here's the quick download location for it. It's download from computerforensics.sans.org downloads. The only requirement for the download, by the way, is that you have a portal registration address. And the main reason for that is to prevent it from too many people linking to it at once, and we can also help throttle the bandwidth during major releases. We actually used to have it online with no portal, and we actually ran into some problems of too many people trying to link to it at once, and it ended up crashing at these SANS servers, which was fairly bad at the time that it occurred. And again, during this session, if anyone has any questions about the SIFT, or if anyone wants to bring up anything, please do so in the question window, or also drop it into a hashtag into Twitter. I'll be glancing over there from time to time. If someone does ask a question through Twitter, if someone wants to repost it in the window below, that way I could probably see it a little bit easier. So if anyone's on Twitter and asks a question there, either or, but if someone wants to drop it in, I'll try to be looking at Twitter every now and then, but at the same time I'll be primarily focusing in on, there's a 404 page not found. That's not good. Make sure you spelled it correctly. Maybe there is a 404 that they knew I was about to do this. Okay, so we'll put a block that no one could download it. So the SIFT workstation, the way I initially discuss it with individuals is think of it like FTK or ENCASE. Think of it as an application rather than a separate operating system. The way we have it currently developed is in two different forms of distribution. The first distribution is in a virtual machine, and VMware is what we chose for this initial virtual machine, which you could utilize in VMware Player very easily without any restrictions. It's a free tool that's out there. So the virtual machine, the reason why I like the virtual side is that you could still give it a lot of memory, give it multiple processors, depending on your hard drive, it actually will function quite easily, almost as fast as your entire computer if you dedicate enough RAM and CPU processing to it and not hogging anything else on your host box. Alternatively, we also distribute an ISO, and it's an install ISO. It's really not meant to be like a bootable acquisition ISO. It's mainly that you'll take this ISO, you'll drop it into a workstation, boot into it, and the idea is that you would then install it as a dedicated SIFT workstation instead of having it run within the virtualization of VMware. Also, for those of you who like any of the other virtualization products that are out there, you could also use the ISO to install a guest OS on any of the other virtualization products that are out there. So for those who are not happy that we only dedicate to VMware only, you'd be able to take the ISO file that you download from computerforensics.sans.org, and that you would be able to install that in your secondary virtualization platform of your choice. So the flexibility is definitely built into it. So going back to the idea that it's more of a toolkit, like you would function with FTK, the only downside is we don't have as much GUI stuff built into it that a lot of people are familiar with when you use FTK or an ENCASE or any of the other commercial tools. Most of this is a lot of smaller tools that are pasted together that includes a much greater capability as a whole. And in some cases, we end up being a little bit more bleeding edge than a lot of other capabilities that are out there, mainly because it's a lot easier for us to get brand new code into it and do a release than a lot of the other commercial vendors are able to do. So we end up being a little bit more on the bleeding edge side than you say an FTK or ENCASE product probably is. That comes with its downside though. Obviously, things need to go through more testing and evaluation, and things end up potentially having bugs in it. So you constantly need to be upgrading and looking at revising the SIFT workstation for the latest versions. So in the end, our goal here is to create a portable forensic workstation for free that you could use for your investigations. And as I said before, think of it as in-case or FTK, but for free. And for those of you just getting into digital forensics, it's a great capability to use as your first digital forensics processing platform. Or for those veterans out there looking for something else to move it beyond what you're able to do with commercial tools, this ends up being a great capability overall. One thing I will note about the SIFT Workstation is that even though I use the SIFT Workstation almost exclusively in a lot of my investigations, I also tend to go back and use FTK and encase quite regularly. Depending on the case, especially if it's something that is, has a lot of data to crank through, I might set it up on auto-forensicate from an FTK or an encase platform so I could do quicker string searches, or I could want to do massive picture recovery on some things like that, email analysis, things that there's a lot of data to go through instead of using the SIFT Workstation. Typically, I'm using the SIFT Workstation in situations where, in my mind, that it's more like a scalpel. I really need to dig deep for something, not something that is, I'm looking for doing a massive amount of processing for, even though I have known people to use it for the larger cases as well. I tend to use SIFT as more of the, the scalpel instead of the sledgehammer capabilities. Now, all of your analysis capabilities are built into the memory analysis side. In one location, we have memory analysis, timeline analysis, file system analysis, and a lot more. And I'll demonstrate some of those capabilities in the SIFT Workstation right here. When you initially install the SIFT Workstation from the VMware side, the memory is currently pegged at 1 gigabyte, and the CPUs are 1 CPU. So from the start, if you want to increase the capabilities of the SIFT, you can increase the memory and increase the number of CPUs. Now, to go ahead and take care of one question that I know a lot of you are going to be having out there is, well, what about moving to from the 32-bit architecture that you're currently on, moving to a 64-bit architecture? And we are planning to do that with SIFT 3G. So SIFT 3G, go ahead and write it down, and saying that it's going to be probably going to be built on a 64-bit platform for Ubuntu, and that will take care of with a lot bigger, more processing capability, more memory, and just an overall more pleasurable experience. And I've had a lot of requests out there for the 64-bit side, so expect it that the last couple versions of the 32-bit with what we'll see in the next few weeks, and then as we start switching over into 3G development, that is going to be a 64-bit based architecture. The login and password for the SIFT Workstation is SANS Forensics, and the password is Forensics. Obviously, if you're using this on your own systems and you want to protect it, definitely want to change it, but from the start, it's pretty easy to figure out how to log in the machine. You'll log in as a normal user, and if you need to elevate your privileges to do something useful like mounting disk images, then all you need to do is just type the command sudo su with a minus. That will get you there. Now, your desktop, and I'll be switching over to a couple demos here in just a few minutes. Your desktop, when you initially log in, will look like this. Now, actually, I'm going to go ahead and see if I can switch over because the new desktop has some pretty cool things I want to show you. Let's see if I can get it up and running here. All right, so here's the current desktop, and it'll take a second to reveal itself through the Webcast connection here. But when you usually fire up the desktop, there's a lot of documents that are already existing that are sitting on the desktop of the SIFT Workstation. And a lot of these are cheat sheets that I really, that a lot of others, including myself, have put together to aid individuals in working with the SIFT Workstation. So if you're brand new to it and you're really not sure how to do memory forensics, there is a dedicated memory forensics cheat sheet right here on the desktop, and this is tied to the volatility tool set. There's a cheat sheet for timeline analysis as well that's also on the desktop, and there's a catalog / cheat sheet which is multiple pages for the overall SIFT Workstation here. Now, for a complete listing of the tools that are currently embedded in the SIFT Workstation, there's a single document here that what I've tried to do here is link to the home pages of each one of the tools, that if you do open up the tool descriptions and you want to know specifically how to use one of the tools in here, you'll be able to do so. So say, for example, if we ended up having anything to do with the VMDK, we could do search through the document here and see if there's any mention of VMDKs inside the SIFT Workstation. For example, there's a command, QEMU, that'll help us convert images to another format, such as RAW to DMDK or DMDK to RAW, in utilization of that command. Then there's some blog articles here potentially that I link to that also discuss it. So what, when you start looking at the overall output here, what we've tried to do is list two different capabilities that are within the SIFT Workstation and link to external blogs that also might discuss some of those capabilities that are out there. How do you get tools inside the SIFT Workstation? A lot of these either I've discovered, that part of my team has discovered, or there are individuals out there that send me a link and saying, hey, I'd really like you to include tool X as a part of the SIFT Workstation. And if it's not GPL'd at that point, typically I'll reach out to the author and ask them permission to include it. And if the author's willing, then we'll also share it within the SIFT Workstation. So let me go back to my slides and moving forward. Please ask any questions along the way here. For the file system support, one of the great things about the SIFT Workstation is it has a multitude of file system support already built into it. From being able to do Mac analysis with HFS, Solaris, UFS, Linux ext2, ext3 with upcoming support for ext4, Windows, FAT, and NTFS. No exFAT though. Hopefully that'll be coming out shortly as well. And then for evidence image support, one of the things that you should probably do is take a look at the fact that we can work with EO1 and the expert witness format, RAWDD, and the new and open source advanced forensics format, the AFF format that's out there. About the new encase format, we are not compatible with the new encase image format yet. This is still, but again, I've encountered a lot of people using the older format at this point. So typically what will happen is one of the things that you'll want to do is when you first gather your images, you want to be able to mount them within the SIFT Workstation, and there's multiple different ways to do this. But when you're mounting a partition or volume, you can mount a partition volume, you can mount a physical disk, or you can mount any of the forensic image formats that are out there. And when you mount them, typically what you'll do is you'll mount it into a directory called the cases, in the MNT directory. And I'll do a quick demo here to be able to show you that, being able to access and mount multiple disk image formats that are out there. There is a question from Eugene. Question 1, how to avoid imaging a lot of 500 gigabyte drives? How can we use a SIFT kind of sniper forensics? One of the things that you could do with the SIFT Workstation, which is actually not in this presentation, is that the SIFT Workstation is 100% compatible with F-response. And what I've been doing for sniper-like forensics is by using the F-response dongles to be able to mount the remote hard drive within the SIFT Workstation and then perform memory analysis or timeline analysis from the remote system from afar. And it's a very good point because it actually ties back into the mounting disk images that within the F-response capabilities, you now have full capability of either mounting a remote Windows system or a Linux box or a Mac machine into your SIFT Workstation remotely at will without any problems whatsoever. So that ends up being a really kind of cool capability that's out there. If you've never seen F-response, I'll go ahead and just type it in here. It is a bidder tool, and I would recommend it if you haven't seen it before. And they do have a really cheap capability called F-response Tactical. Not cheap in terms of quality, but cheap in terms of most people should be able to afford it. Under $400, I think, to be able to get remote capability at a basic level inside this SIFT Workstation. From an enterprise level, being able to do multiple machines, multiple analysts to multiple different workstations, they do have F-response Enterprise, which again, for a commercial capability, it is one of the cheapest ones that are out there in order to be able to make this compatible. So that's what I usually recommend for the sniper-like forensics using the SIFT Workstation without having to first image 500 gigabytes and then work with the remote, work with a local disk image. You can use everything we'll talk about here remotely and be able to see the hard drive as you work across the wire. So F-response is that capability. I don't know if it's easy. If someone does have another capability out there, you can do the same from remote on from machine to machine for free. Please let me know. I do know Google Rapid Response, GUR, and some of the other capabilities out there are being developed, but I haven't seen anything else that's actually released yet. So I do know there's some people looking into it for an open source capability, but I'm not sure if anything's been released. But there's a lot of things I haven't been exposed to, so if there's anyone out there has any ideas on how to do a free solution for that, please let me know. So what I'm going to do is just quickly switch back over to my desktop, and I'm going to show you several capabilities here from the basic side of how the SIFT Workstation works. Now, I do have some links at the end of this that'll take you to documents that'll discuss how to do the mounting and how to be able to get access to your disk images. First thing I'm going to do is elevate my privileges to admin level, root level privileges, and go back into my cases directory where I'm going to be keeping most of my evidence. So in here I actually have multiple different pieces of evidence. I have a raw memory image, I have XDD Blake, a standard NTFS image, and then in the Windows 7 32-bit in Romanov C drive image, you do a directory here, I end up seeing most of the EO1 expert witness file format images. But before I go to that, what I'm going to first do is show you how to mount the standard XDD Blake. In this case, it's a, can't type it. This image here is a, and I'll show you the size of it right now, is a raw image. Let me give it the right options. There you go. 1.2 gigabytes in size, fairly small. And to mount this image within the SIFT Workstation is fairly simple using the mount options. Again, it's in the cheat sheet, but there's also a blog article at the end of our notes here that will give it read-only, loopback, show sys files to be able to show all of our $ files within the C volumes root directory. And you also give it a streams interface equals Windows. The reason for the streams interface equals Windows is now we can actually see alternate data streams and call it from the command line, like on Windows using the colon. I'll point it at the XDD Blake image and give it a mount point. In this case, my mount point is just going to be mount Windows mount. I press return, I CD into mount Windows mount. I can now see all my files and folders. This equivalent type of tool that's out there is FTK Imager that will be able to get you to mount. There are no restrictions on permissions though. So if I CD into system volume information, it doesn't say, hey, you can't do that, like you would from a lot of Windows machines that do free mounts. FTK Imager also doesn't have that problem, but at least we can see all of the $ files as normal through our disk image. And so this gives us kind of a basic capability to get access to it. The other great thing is from our Windows machine, if I go into my SIFT Workstation, which I already have 2 shares set up, which is the cases folder and the MNT folder for mount, I go into the mount folder under Windows Mount, and I'll also now be able to see all the files and folders from my Windows machine. So for anyone out there wanting to have a dual Windows and Unix environment, this provides you that capability, and it's one of the things I tend to use quite frequently, is I can use any tool on the same disk image to be able to parse a PSC file on one end, or be able to go to another box and be able to, on my Linux side, and be able to use some of the Linux-only based tools that are there. So that's my first demo, is to be able to just do a simple mount of a raw disk image. And for my second demo, it's a little bit more complex, but I can first unmount my Windows mount, and I forgot to, excuse me, you have to make sure you're completely closed out of on all your windows, including the one I'm in right now, to be able to unmount the Windows mount side. So currently I don't have anything mounted there. Again, it's clear, it's empty. So now I'm going to go back into my cases directory, and here what I'm going to end up doing is going into my Windows 7 machine that I've imaged with FTK Imager, where we see all of the, in this case, the standard expert witness file formats. And again, in the same blog article that's at the end of our notes here, what you'll see and what you want to be able to accomplish is to be able to mount any of these expert witness file format mounts into our disk image to be able to get access to it like it's a regular disk image. A lot of forensicators out there, what they'll end up doing is have to do an image conversion from the EO1 format to a raw format. You don't actually need to do that within SIFT. All you have to do is use a command called mount_ewf.py. You'll point it at the first EO1 image, and then mount it at mount, and this is where I say mount expert witness file format, mount_ewf. You'll get your prompt back, and I'll go into the expert witness location, And now in here, if I do it long listing, this image for the Win7 in Romanov C drive is my raw drive for the export file format that we have here for EO1. It combines everything and uncompresses it, and it doesn't really convert it. All we're doing is just like I'm clicking on a zip file, it's just combining everything and putting it together via memory. It's like putting a lens on that hard drive, and you're looking through the lens uncompressed at the raw data. So at this point, once we have access to the raw image, same as before, we'll do a read-only loopback show sys files streams interface equals Windows. We'll point at the raw drive, and then I'll mount it at mount Windows mount. And I'll CD into the mount Windows mount partition. And now I can see all the files and folders just like I saw them before. And from my host machine, I can now CD into the SIFT Workstation as normal. So what we see here in the mount directory, I should now be able to see the Windows 7 directories in this case, from my Windows box, which include the users directory, and Romanov is the username for that specific user. All right, I do have a question. Let me switch back to my normal slides here. So the question is, for chain of evidence, do you need a special hardware to copy a disk, or can you just copy an image, to work from? Typically, what I recommend folks to do is, since the SIFT Workstation has full capability to a USB device, or even you could connect it to a SAN, is that depending on where your evidence is currently located, if it's on a removable media, such as a external drive, you'll be able to plug the USB adapter into the SIFT Workstation and work directly from that. Or, and if you want to use a write blocker on the original evidence, you'll be able to do that as well. If you're connecting to a SAN, all you have to do is an NFS mount, or if it's a UNC Windows share, you can use the mount command to be able to mount one of the remote shares on your storage area network. So it really depends on where your evidence is at, and typically it's just getting access to the SIFT to your data store that contains your evidence. One of the great things within the SIFT Workstation, if you do have evidence that you are working with directly into it, and I've learned this from my good friend, trying to share my desktop again, my good friend Hal Pomerantz, is that, let's say, for example, you did copy your evidence into your case and you wanted to make sure you didn't accidentally clown something up, which we always have a fear of. You could actually do a command called chatter, change attributes, and we do the +I option, which is to set the immutable bit against our evidence, in this case, xpdblake.dd. And when you do so, at that point, that evidence, you cannot remove the evidence, change the evidence without first removing the immutable bit. So basically, it's another restriction you can actually set on your evidence to be able to do this. This capability, by the way, does not exist within Windows. There's a couple hacks you can do to get something like that on Windows, but Hal has a blog out there called Command Line Kung Fu that they specifically talk about the comparison between chatter +I and the same capability you have on Windows. And it is 10 times easier to do it within the Unix side to be able to protect evidence using the change attributes option. So it's one of the things that you would be able to keep track of. All right, so going back to my presentation, so just being able to mount the evidence ends up being one of the first things you want to be able to do with the SIFT Workstation. And then once everything's up and running, you want to be able to access things from Windows shares. The Windows shares, again, you could either go to the IP address or just type in SIFT Workstation if you're running this within a Windows host. Pretty easy, pretty simple. It's already set up for you. And for anyone who's advanced users, all you have to do is go into Samba config within the administrators on the Ubuntu side to be able to change or add additional directories and to be able to share this out. Now, please note, this is an anonymous, no password needed share. So you obviously could password protect it, and those of you working the domain could actually set domain credentials to be able to access this as well. But by default, it is shared out, so you locally could get access to it without having to input a password. But for those who want to go a little bit further into configuration, can use so through the Samba configuration. All right, so where are all the programs installed? They're all under user local source or user local bin. There's a variety of programs already installed, including the Sleuth timeline generation, Volatility are some of my favorite to be able to use within the SIFT Workstation. There are some GUI programs that are out there. DFIR's PTK is installed, Autopsy is installed, PyFlag is installed, and others out there for those who do appreciate the GUIs on the free side. So let's talk about, oh, here's where I thought, two double slides, bad on me, but here's that slide that I basically have discussing where the blog article is and how to mount your images. And if you wanted to be able to see that link, you can come back here later. Click on it when you download the PDF in general. All right, so useful SIFT utilities that are out there. Now, we'll run through some of these. These are some of my favorite tools that are within the SIFT that I was going to talk to some folks about. There's Registry. For those of you who like running Registry via the command line, you have rip.pl that's built into it, plus all the latest Registry plugins in the user local source plugins directory. Yaru, which is a registry analyzer, and deleted.pl will recover deleted registry keys. Exit tool is a very great tool, very powerful tool. They could just, like the command file, you just point it at a file and it'll rip out all the exit data. And libpff, which is a mail examination tool, who Joaquin Metz created that tool. It's a really cool capability. Now, within the SIFT Workstation, to be able to regrip with the SIFT Workstation, I don't like the GUI side because the GUI side doesn't allow us to do scripts easily to run. So I have a lot of scripts when I'm pre-processing evidence that once I have the disk mounted, I press go, and it'll actually start ripping all the registry hives across the system and dropping it into the cases folder. So you can actually have a script of all the commands built out. Just a simple bash script does this for you. That'll basically recurse through the directories looking for where the int-user.dat hives are. How you use it, it's so simple to run. You do rip.pl, you get .-r at the hive file in question that you want to rip. -f is the hive type. So this example I'll do here is going back to our desktop. So I have a mounted directory. So we'll go into Windows, and we'll go into Windows directory, System32, and go into the config directory, where we have a lot of our hive files that are sitting in here. So let's say, for example, I want to do rip.pl, -r as my SAM hive, and make sure we have it, it's uppercase because capitalizations do matter. -f, and we give it either SAM security software system, and I'll pipe this to less, so I'll be able to rip it out correctly. And all this does is drop it out to my standard out via my command line, and gathers all the Registry information from the SIFT Workstation. And that's all the command does. You could do it against any of them, or in this case, what I do is redirect it to my cases folder, and I can write this to sam.txt for later examination, even from my Windows machine. Going in cases, I could click on sam.txt, and of course WordWrap's not on, but at least there's all your data that you'll be able to get access to from the running of that command. So ripping from your registry is quite easy. Most people prefer the GUI side, but if you want to do scriptability and have things that you can do more sniper forensics, just a single command, rip everything that's in there, come back after lunch, and there's all your data. That's one way to potentially accomplish that. So RepRipper in the capability, really nice capability that Harlan Carvey has created here, and a lot of people are now contributing to on the plugin side. So everyone, thank you for all the plugins that are out there that are continually being built within the RepRipper interface that Harlan Carvey has put together. Another capability that's out there is it's kind of combined actually to be able to examine deleted registry keys. The first is deleted.pl. You can point at a hive file, and it'll rip all the deleted keys out. The second is a tool called Yaru. And Yaru is a capability that is a GUI capability released by PZWorks. And again, let me go over to my demo to show you this one. So share back entire desktop. To be able to execute Yaru, I'll just go to my forensics drop-down menu, and it's sitting in here. We'll do File, and we'll just simply open a hive. The hive that we're going to open up is sitting within my Windows mount. Let's go into the user directory and go into in Romanov, and we'll see the int-user.dat hive here. Double-click on this, and what it will do is basically it's like the registry viewer where we'll see all of the different files, keys and values that are within the registry viewer. And then down at the bottom, we'll have both unallocated space plus any deleted keys that it has been able to find that in. And this is where we end up finding if there's any deleted information in here, where that is. And there's not a lot, but in this example where we only have one key that is deleted, but if you actually go back and look at the slide that I have, this is what it looks like when someone uses a privacy cleaner across the system, where you see recent docs and the MRU list that are cleared. And there's a bunch of different locations within the registry that are actually cleared, but again, the data is still recoverable fairly easy using a utility like Yarrow to be able to help us out. Another great capability is libpff, written by Joaquin Matson, the source website that you see here. And one of the things I end up doing with this is extracting Outlook data from a mail store. It functions extremely quick to be able to do this as well. So what you see the command here is the PFF export -Q, which says quiet mode, -F is all, meaning it's going to rip out HTML, RTF, and text for the defaults. -M is going to say all for allocated, orphan, and recovered items. So you could actually just have it go through and pull out all of your deleted data and then put in your Outlook PST file. So this example here that I'll have, I have a PST file for in Romanov. And go back into my Windows mount for her specifically. Users in Romanov, app data. I have to remember where it is. I think it's local, Microsoft, oops, Outlook, and there we go. I always have to remember where it is. Or maybe it's in roaming. This is why we created that poster, by the way, so I could always look this up and find it. Oh, shoot. Okay, I can't find it right now for this stupid demo. Oh, hello. Did you lose me? Hello, did you lose me? Just the app share. Okay, not sure what happened there. You can still hear me, so you heard me cussing there for a second, did you? Hold on, let me look up the, I can't believe I have to do this every single time, because I always forget the exact directories where things are. Okay, 2 seconds as I'm looking this up. It just goes to show you can't remember everything, where everything's at, but I do know where to find it pretty quickly. Poster, there it is, okay. So someone's going to look it up probably faster than me on here. Oh, not sharing my demo screen. Oh, got it. Okay, so here you go. App data local Microsoft Outlook. Should be there. So why didn't I find it? App data local Microsoft Outlook. No PST file. I'm in the wrong location. Well, maybe there's no PST file on here. Thought there was. Okay, so if there's no PST file on here, then my bad. Really bad demo that I was going to do here. But okay, well, no demo on that one. I thought there was one in that specific location, but I did not find my Outlook PST. All this is going to do for you when you run it is going to basically create a top level directory, and then it's going to export into subdirectories within your SIFT Workstation all the different emails handled by message header that's out there. The interesting thing when I start looking at this is that for those who want to use grep and find to be able to find specifics, it's really easy to use this capability that's out there, and it makes heads or tails of a PST, and the attachments are automatically saved as the original file name. So you can actually go through there and do a grep for, or a find in this case for, like all PDFs that have been sent to this user if you're looking for an APT-like case. Other capabilities that are out there. The volatility tool set is inside the SIFT Workstation, and it's in quite a capability. Now, of course, there's a question, Rob, did you get the volatility timeline or fixed in the latest SIFT yet? We're working on it. One of the things that we found for the timeliner capability, and this is something that I've seen also that Jamie has said across the board that is a challenge for it, is that we actually have to have the different versions of the volatility that are out there. And I'll show you the different versions that are actually inside the SIFT Workstation. So we actually have 3 different versions of volatility. We have the Volatility 2.0 stable release. This is the one that supposedly had Timeliner working in it, okay, but there's still a bug in there. I'm still trying to troubleshoot that. But this is the one where we have a stable release, which is the last hard release with volatility. We have the SVN release for volatility, which this is the bleeding edge version. And then we also have a volatility fork, Volatility 2.0, that was forked by Jesse Kornblum for our new and upcoming Forensics 526 memory forensics class, which is going to be a 5-day course dedicated to memory analysis, which are betas for that course, by the way, are upcoming later this summer in August and one in September, probably before we officially have the course out there in front of folks starting in December. Now, if as a result of the different versions of volatility, we actually have vol.py, which is attached to the stable release. We have vol64, which is attached to the SVN release. And then we have vol.sans, which is a link attached to the volatility SANS release. So the reason why we have multiple versions of volatility is that things break between the different versions. And even the folks that working on the different tools out there admit, and I learned this from Jamie, Jamie Levy at Glida, that the different releases end up, because of where they're at, end up basically one thing actually might deprecate another. And so like Timeliner is a good example of that we try to get Timeliner working in one, but it might not work in the SVN release version. So that's one of the reasons for the multiple different variations that are out there. And so as a result, we potentially continue this trend, and we'll try to, I need the next version of this, SIFT.2.14. I already know where the problem is in Timeliner, and I'll basically refactor that in and get Timeliner working that next time. So great question to Christopher McCann. But one of the things you'll start to see in our releases is the multiple versions of volatility, mainly because I want to keep the bleeding edge version, so the latest coolest stuff that's out there can be included. But I also do realize that some people definitely need the stable release for the hard versions as well. So great question within the volatility toolset that's there. So going back to our notes, we actually have a 6-step process for analyzing memory analysis within the SIFT. Step 1, identifying rogue processes. Step 2, analyzing process DLLs. Step 3, reviewing network artifacts. Step 4, look for evidence of code injection. Step 5, look for signs of rootkit. And then step 6, dump suspicious processes and drivers. Now I'm not going to go through all the different steps here how to do that, but if you actually go back to your cheat sheet that is on your SIFT Workstation, take a look at your memory forensics cheat sheet, and you'll notice that for these different steps, they're actually identify rogue processes listed, evidence of code injection, analyzing process DLLs, dump suspicious processes and drivers, reviewing network artifacts. The cheat sheet basically lists the command how to run it, and so when you point out your memory image, everything will work okay. So the cheat sheet is what I usually point people to, and you don't have to worry about compiling volatility on your own, but you do have to be familiar with that. It's going to be 3 versions of volatility that will be on here. One's a bleeding edge, one's a stable release, and one's the forked version for Forensics 526, Jesse Kornblum's new course. And that's just, again, multiple reasons why, but at the same time, it's a great tool. I highly recommend it for anyone who's doing memory forensics work that's out there. And again, the SIFT Workstation definitely has it already built, so you don't have to worry about building that on your own. All right. So moving forward, in addition, and this is basic how to use volatility, is you run volatility against your image, run the plugin, and set it for your profile. Highly recommend always use the profile option, even if it will probably work in some cases native, but in some, like doing image copies, extracting hibernation data from a raw memory image from a hibernation file, makes it a lot easier to do so from setting your profile correctly. One of the ways I make sure that everything's set up, there's a lot of environment variables that can be set up, not only for the profile, but for your memory image location. And on your cheat sheet, it also lists these. for export volatility location for your memory image, and then you export volatility profile for your profile as well. So all you have to do is run vol.py, type the plugin, and automatically will output the different capabilities of that parsing element, such as network connections or processes from volatility within the SIFT. And here's just a cheat sheet that basically talks about that, and just a call out from our slides in general. Timeline analysis is built into the SIFT Workstation. There's two capabilities that are built into the SIFT Workstation. The first is file system focus, which is from the Sleuth kit version called FLS. There's also the super timeline version, the log the timeline version, which is the obtain everything. But this is also pretty much targeted at Windows only, where FLS has more file system types that it's able to parse, including Apple, Solaris, Linux, and Windows, whereas the log the timeline is almost primarily at this point focusing on Windows analysis and doesn't have as much capabilities beyond that for limited for Linux and Mac, but not near as much as what we have for Windows. There's another question from Eugene. When you talk about log the timeline, how do you use log the timeline SIFT mounted on infected hard drives, not on an image, same 500 gigabyte, 1 terabyte, one? Thanks so much. How do you use log the timeline on mounted hard drives, not on an imaged? Maybe, Eugene, are you basically asking how to use the command log the timeline SIFT, or is it your second part of the command is what you're trying to focus in on, which is the how do you be able to do that against a very large hard drive? Maybe if you could clarify that question, it would potentially help me out. Okay, how do you do it against a very large hard disk drive? It's interesting you say that because without imaging it. The same thing in F response, we'll be able to do it against a remote drive in using log the timeline and point it at the dev STD, and then log the timeline SIFT will do the attempted mount of it just like you would from a standard hard drive. There is a challenge with the much larger hard drives, not about data space, but if you have like a lot of files that it needs to parse. I've actually encountered in some very rare circumstances where log the timeline will fail because too much is in memory. It doesn't, and that's one of the reasons going over to a 64-bit architecture might help out with log the timeline processing. So on a very, very massive amount of elements that it needs to parse, log the timeline I have noticed has had some issues with. So I usually have to do log the timeline against a targeted timeline and manually piece some things together. And that's on some hard drives that almost has 1 million artifacts to pull together. On an average Windows system, you're looking between 70 and 100,000 different artifacts, whereas Windows 7 installs like 30,000 files by default. So on some systems like databases and others where you have, or file shares, where you potentially have up to 1 million different artifacts on it, I've seen log the timeline sometimes fail based off of some memory management stuff. I think that's what it is. And one of the individuals I talked to said he fixed it by switching over to the 64-bit platform. So the SIFT to timeline analysis procedure, this is what I usually run through with people, is you determine the timeline scope, narrow down your pivot points. Your pivot point is basically what are you focusing on in your timeline of interest. Potentially when something potentially happened. Maybe you're looking for a file type. Maybe you're looking for when a specific process started. Determine the best process for your timeline creation, either automated or you do targeted. Filter your timeline, which includes deduplication of multiple different timeline artifacts that are the same, and then finally analyze the overall timeline. And then, of course, you can use your evidence of cheat sheet in the poster to be able to help you out here. There is a wonderful cheat sheet that is created by David Nines, and I'm not sure if he's on this presentation or not. I'm just quickly looking. But David Nines from KPMG put this together, and if you look at the slides here from start to finish, and this is also distributed within the SIFT Workstation, it goes step 1, download SIFT. Step 2, boot into it. Step 3, elevate your privileges. Step 4, connect your image to the SIFT. Step 5, mount it. So there's multiple different ways to step through here, and basically he creates an overall process for creating a log the timeline output from your hard drive evidence. And if you wanted to, again, what I usually do if I'm trying to do this remotely, sniper forensic style, then what I'll end up doing is using F response or another kind of capability like that. Now, for those of you looking for more in-depth resources for creating this via the SIFT Workstation, there's a ton of articles that I've written online and blogs that you'll be able to go reference or associated with the SIFT Workstation in general. that you could go through. And I'm not the only one who's done this. SIFT Forensics and others have also put things together as well using the SIFT Workstation. So if you just use the word SIFT and forensics and timeline, blog for keywords into Google, I'm sure you're going to run across multiple different blogs that will discuss this. For data extraction, on the SIFT side of using data extraction, there's a great tool that's within SIFT Workstation, which is actually much faster than in case and FTK, called Bulk Extractor. This is a new tool written by Simpson Garfinkel and his team, and runs 48 times faster for data and stream-based extraction than in case or FTK. One of the reasons why it's multi-threaded, so those of you who have multi-core systems are going to be really seeing a benefit here. It'll find stuff that a lot of other tools miss. It's going to automatically detect and decompress zip stream data. PDF extraction, if it discovers a hibernation file, it'll also be able to extract the data from the hibernation file. There's a ton of built-in scanners as a result of Bulk Extractor as well. It'll automatically pull out email addresses, credit card info, AES encryption keys, prefetch file information. It'll decode B64 text decoding, GPS and Garmin enabled JPEHs, domain names, phone numbers, and a lot more. The easiest way to run Bulk Extractor, by the way, if you go back to my system here, if you wanted to, there's a GUI. So for those of you who like GUIs, you could run this through a GUI, and basically you invoke it by just saying BE Viewer, stands for Bulk Extractor Viewer. This brings up the overall viewer for Bulk Extractor, very similar to if you've used any other GUI tool. But you can actually use tools, run Bulk Extractor, and you can point it at an image file which has EO1, AFF, and raw image data parsing capabilities. You set the types of scanners that you want down the right-hand side. You could use alert list files. You can find specific regex in there in a specific directory. But this does a really decent job of being able to extract stream-based data. Even though it's so much faster than case RTK, this is still a tool that will take some time to run. It's not something that will be done in 5 minutes. So when you set this up to run, make sure that you leave your workstation alone for about a good day or so. But it still runs much faster than what you'll be able to do from comparable to the commercial side that's out there. Another huge benefit of this is it automatically produces histograms of certain data types, URL search terms, credit card numbers, telephone numbers. So you could actually build a profile, maybe the same telephone number is found in that disk image like 800 times. It'll list that same phone number, even if it's in an email or a hibernation file and temporary internet file. And it makes it a lot easier to be able to do scanning and saying, wow, that's a number that is quite common, more than any other number that we've seen here. Same thing for IP addresses, URLs, search terms, and a lot of other things that it will concatenate everything together and tell you how often that one string is actually found in the overall image. This tool, keep your eye on it, by the way. It is a release for this tool is happening quite frequently, and Simpson Garfinkel and his team are building in new scanners routinely. Now that they have the base done, they're working on a lot more plugins that are building into the backend scanner for this. So it's quite an exciting capability that's out there. And you can run this from the command line too as well. Just run Bulk Extractor, point it at output directory, and typically what way I'll use it is I'll point it at a regex file of a list of regular expressions within a file. Use the -f option, and you point it at either your EO1 image or your raw image, and it'll be able to extract your data for you. One of the things I definitely recommend is and make sure you enable the AES scanner in case it's able to detect any AES keys through your images using the tool Bulk Extractor overall. So Bulk Extractor, a huge capability that's in the SIFT Workstation, automatically compiled, ready to go out the door. And then finally, the Sleuth kit. Now the Sleuth kit is a nice capability that is within the SIFT Workstation. It's been there from the beginning. It has data layer, metadata layer, and file name extraction-based tools. The cheat sheet on your desktop of your SIFT Workstation is going to tie into this. And the great thing about it is it's going to do a really good job of being able to parse either Mac, NTFS, FAT, Mac HFS, and that's what I mean, Solaris UFS, or ext2, ext3 file system types. And I tend to use this especially when I'm doing scalpel-based forensics, that I'm looking for something very specific through my disk image that others, or do verification of different, capabilities that I'm not quite sure I trust. So I potentially go into the Sleuth kit to make sure I can look at the raw data fairly quickly. So I do want to do one extra demo here that is a new capability that's going to be coming out in the next version of the SIFT Workstation. And that is using a new tool written by Joaquin Metz called libpff. And what I'm going to do is just show you how easy it is to compile new data things in the SIFT Workstation, so if you wanted to use this already. So this is a new tool that Joaquin Metz released from the Google team. And to be able to compile something within the SIFT Workstation, fairly simple. All you have to do is extract it, go into the directory, in this case libpff directory. And what I'm going to do in here is do a file listing. You'll see there is a configure and a make. I'm going to do make install. And what this will do is automatically just go ahead and configure this tool set within the SIFT Workstation. So if there isn't another tool that's out there and you wanted to add it to the SIFT Workstation, all of your compilers, Perl, Python are already built into this. So you can configure this and make it useful for you on the back-end side. So once this is done compiling, what I'm going to do is, remember that Windows 7 image that I have located in my cases directory. Here, if I go into the Windows 7 32-bit in Romanov C drive, I actually have a Windows 7 image that I'm going to be that has volume shadow copies enabled on. So once this is finished compiling, what I'm going to do is I'm going to point it at the this file here, so I could be able to get access to it. Now notice, in order to do this, the first thing I need to do is get raw access to that file. So I would need to do that mount ewf.py, pointing at that first image. In this case is mount EO1, and then pointing at the mount EWF directory. Now this has already been done for me because I did it earlier, and that's where my Windows 7 32-bit in Romanov C drive is currently located. So once this is all compiled, I should now be able to see that there's two tools that have been created, vShadow Info and vShadow Mount. So to be able to run this tool against that image, I'll do vShadow Info against my Windows 7 in Romanov C drive. And when I press return here, LD config. Got to remember to do that. All right. Now when I run it, what it's going to do is go through there, and LD config basically reloads all the different libraries and shows in my snapshots there are currently 1, 2, 3, 4 snapshots, and it talks about where those different snapshots are currently found. One on April 4th, March 31st, March 23rd, and back on March 15th, about one a week approximately for this disk image. So to be able to get access to these, what I'll end up doing is I'm going to create a new directory called mount shadow. And from the mount shadow directory, I'll do mount vShadow mount against my image, Windows 7 in Romanov C drive, and point it at my mount shadow directory. I press return, let it crank through this, let it cook for a second, and now I'll CD into the mount shadow directory, and I should now see the 4 mount points. Now what we have here is, instead of what we saw before as a single raw disk image, each one of these is actually a separate, notice our original image was 25 gigabytes, each one of these is a separate raw disk that we now have access to. So to be able to mount these, all I have to do is I'll make another directory, mount shadow 1, 2, 3, and all we need to do is mount-o read-only loopback show this files, and I'll point at VSS2, and I'll mount shadow 2. See, that's the one that I potentially have interest in examining back at that point in time. I do the mount. Now I can see all the files and folders from that earlier point in time. So what vShadow mount is, again, this capability is going to be in the next version 2.14, which I'm going to be releasing in just a week or two. Or you could just download it now from, if you do a search online for libpff, you'll be able to download it from the Google Code site and also just follow along with what I did. But this also provides a good capability, saying that I can't keep up to date consistently, release this tool every week, but this does show you that you can get access to the different shadows or different tools that are downloaded, and in this case, to be able to get access to the different shadows that are potentially out there. So some really cool capabilities that are upcoming within the SIFT Workstation that allow you to pretty much be able to handle any type of data that's out there. Really easy capability to get access to the raw data within each volume shadow copy that has been created within the disk images. So there's a lot more things like this that are coming out in the future. And with the SIFT 3G folks, I am looking at trying to set up a dedicated update site. So for some tools like this and others, that we could automatically have it feed down to your station, current stations, so you don't have to upgrade your entire machine. You could just upgrade the current one that you're at. And so I'm talking to folks out there about how to do that with the current team that we have in place. So for those of you who are interested in helping out with the SIFT Workstation, please send me a note at arlie@sans.org because I'm actually looking for additional folks to do testing and also additional development that's out there to be able to figure out the best way to be able to keep this capability up to date and free for some time to come. So as we close out here, you basically should have a combined Windows Unix Forensics Lab for analysis, cross-compatibility for Unix and Windows, all your tools configured, everything should be able to run out of the box. Memory analysis, timeline analysis, string extraction, everything you can do with your standard forensics tools. The only downside, it's a lot more typing than most people are usually familiar with. If you're interested in the SIFT Workstation, really becoming a master of it, highly recommend you coming and taking Forensics 508, which is we are all SIFT. It's the only tool that we use in there, but we use the SIFT Workstation, volatility, timelining capability. We show you bulk extractor. We're going to show you the libpff shadow and other types of capabilities, that things you could do with the SIFT Workstation. So you walk out of that class almost really being a master of utilizing the SIFT. So question, when using the SIFT to store images to external media, which file systems do you recommend for a destination drive? NTFS gives wider access, but exe3, exe4 would seem to provide better performance. I've seen NTFS 3G eat CPUs while imaging drive. That is true. Typically what I recommend is a storage area network of some sort, and a lot of those end up being Unix-based. The great thing about exe3, exe4-based systems is that you also could do the chatter plus I to be able to set, in that case, immutable bit against your evidence to make sure that nothing could destroy your evidence. So I'm a big fan of Unix-based file systems. And in storage area networks, usually there's an interface out there so everyone can easily mount them via the remote stores anyways. For anything that's NTFS-based, it's not a complete downside, but at the same time, you can do remote NFS mounts of a storage area network that is NTFS-based as well. It's fairly easy to do, but the only thing downside is you really have to be on gigabit Ethernet to be able to get the throughput that you need to really make imaging and examinations capable. On local-based machines, if you're downloading to a local hard drive, typically having an exe3, exe4 plugin for your Windows machine, that's all that's necessary in order to have all of your external media formatted that way. So I definitely recognize that NTFS ends up being somewhat of a more processing hog, but some of the new capabilities that are out there definitely streamline that a little bit. So I would need to see actual performance testing to make a solid conclusion over one method over the other. So it's a great question. If you're really concerned about it, I would go with the methodology that fits best with you. But I also try to push people to thinking about storage area networks a lot more for having people do evidence or processing, so they're not constantly having to manage external media attached to your computer systems. So here's my email and questions at the end, arlie@sans.org. We'd be happy to answer any more additional questions that are out there. Before we close out, any more questions? I don't see any more questions coming up. Just as a side note, we do have the just released this week, the SANS DFIR poster has been sent out as attached to the Network Security 2012 catalog. So I hope you all have received that. If not, I'm going to be posting a blog article later today that's going to have the PDF of the poster attached to it. So be on the lookout for the Digital Forensics Incident Response poster. And also, for those of you in the EU, I truly hope that I'll see you in forensics. And for those of you attending the summit here in the United States next week, I'm actually flying out to Austin tomorrow to start teaching Forensics 508 on day 1 on Wednesday of this week. So that's going to be leading up to the summit, which is next week on the 26th and 27th of June in Austin, Texas. It's going to be a great time, and I'm going to have a lot of fun with, I think a lot of you that I see on here are going to be attending that. So thank you. I appreciate your time. I hope to see you at an upcoming conference. If not, please keep in touch online, and I appreciate your attendance this afternoon.